Hello everyone, I am Swarnalatha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the non-monotonic transformation of a random variable for both continuous as well as a discrete random variable case. So already we have seen the previous lecture transformation of a random variable. So what do you mean by transformation? Transformation is nothing but, for example, if we are having a random variable x, the x may be either continuous or discrete, whatever it may be. So, I am transforming this random variable into a new random variable y by performing some operation. Here, t indicates what? Transformation or whatever the operation you are performing in the random variable x to get a new random variable y. So, then what is y equals to here? T of x. So, y equals to t of x. Nothing but the new random variable has been obtained by transforming the random variable x or by performing some operation on the random variable x. You are going to get a transformed or a new random variable y. It means for each value of x, it will map to another value in the random variable x. For example, I have given, I am having, let us say, x equals to some 1, 3, 6. Then I am performing some operation on this random variable. So, what type of operation performing here? I am adding just a number 3 to the elements in the random variable. So, what is operation here? T is nothing but here adding a number 3 to the values in x. That is the operation here. Then what you are going to obtain the y is equals to, so 1 plus 3 nothing but 4, 3 plus 3 nothing but 6. And 6 plus 3 is nothing but what? 9. It means what here? In the random variable y, the 4 is corresponding to the value x, the value 1 in the random variable x. Similarly, the value in 3 in the random variable x is corresponding to the value 6 in the random variable y. So, that is the meaning of this one. So, each value in the random variable x is mapping to another value in the random variable y. Now, what you have to do is you have to determine the distribution function as well as the density function of the transformed random variable y if the density function or the distribution function of the non-random variable x has been given. Now, here I am saying here t nothing but transformation. So, the transformation having two types. One is monotonic transformation. The other is non-monotonic transformation, which already have discussed in the previous lecture. So, what do you mean by monotonic transformation? Mono is nothing but what? One-to-one correspondence. Okay. And again in the monotonic transformation, you have increasing and decreasing. So, monotonically increasing transformation and monotonically decreasing transformation. So, for example, the previous example you have taken this. Each value here next is corresponding to a single value in y. Therefore, this transformation is called as what? Monotonic transformation. Then what is non-monotonic transformation? One to many. It means one value in y is corresponding to many values in x. It is called as what? Non-monotonic transformation. Okay. Now, what is the definition for non-monotonic? A function is said to be non-monotonic if the set of values of y corresponds to more than one value of x. Then it is called as what? Non-monotonic transformation. So, here in the non-monotonic transformation, we are having one to many correspondence. So, one value in y is corresponding to many values in x. That is nothing but non-monotonic. So, if you observe one figure here, in this figure, the x-axis represents the values of the random variable x and the y-axis represents the values in the random variable y. What is small x represents? The values in the random variable x and small y represents the values in the transformed random variable y by transforming the random variable x. If you observe here, the value y0, see here, this is the value y0, which is a particular value of the random variable y. It is corresponding to or it is mapping to 3 values in the x. It means x1 is mapping to the same value y naught. So x1, x2 and x3. All these three are mapping to a single value y naught in the random variable, nothing but the transformed random variable y. So this is nothing but what? One to many correspondence. So that type of transformation is called as what? Non-monotonic transformation. So for example here, I'm having x is equals to like -1, 1, 2, something like that. Now, I'm taking y equals to x square. So what does it mean? Just I'm squaring the values of the random variable x, so that I'm getting a new random variable y. So here, what is y equals to t of x? What type of operation here I'm performing? I'm just squaring the values in the random variable x. Then what are my y values here? -1 square nothing but 1 and 1 square nothing but what? 1. And 2 square nothing but what? 4. So it means -1 and 1 in the random variable x are mapping to 1 in the random variable y. It means many values of x are mapping to a single value in the y. So this type of transformation is called as what? Non-monotonic transformation. Now we'll calculate or we'll derive the density function for the transformed random variable in case of non-monotonic transformation. Here we consider two cases. One is continuous random variable, the other case is discrete random variable. So first what are we doing? We are considering a non-monotonic transformation for a continuous random variable. Now we have to measure what? The density function of the transformed random variable. So for non-monotonic transformation, we used to prefer the density function rather than the distribution function. Therefore, the density function of the transformed random variable y, if the type of transformation is non-monotonic and the type of random variable is continuous random variable. Then what is density function? F y of y. Here what is small f indicates the density function, and here what is capital Y indicates a transformed random variable y. So here what is y equals to, by performing operation on x, you are getting y, but you are transforming the random variable x into y by performing some operation. And what is small y indicates? Small y indicates a particular value in the random variable y. If you take here, 1 is, so here 1 is some particular value, 4 is a particular value. So this is nothing but what? A small y represents. So y1, y2. So what is small y represents? A particular value in the random variable y is called as what? Small y. So the density function of the transformed random variable is equals to sigma n fx of x and y mod of dt of x by dx, where x equals to xn. So this is a formula to calculate the density function of the transformed random variable y in case of what type of transformation you are assuming? You are assuming that it is a non-monotonic transformation. And what type of random variable you are assuming? You are assuming a continuous random variable. This is a formula. Let us derive this formula. Okay, so what is here in the previous figure? We have seen that many values in y naught. So many values in y naught. For example, see here. So many values in x. This is let's say x1, x2. So x1 and x2 both are mapping to a single value of y. So nothing but this type of transformation, nothing but non-monotonic transformation. So let us derive this one. So what is the distribution function represented by capital F? So the distribution function of the random variable y is equals to what? How the distribution function has been defined? It is defined as the probability of the event y less than equals to y. So the distribution function of the random variable y has been defined as the probability of the event. What is the event here? All the values of the random variable up to the, it takes up to the value of small y, nothing but y less than equals to y. This is one event actually. So the probability of this event is nothing but what? The cumulative probability distribution function. Simply we'll call it as what? Distribution function. So Fi of y, nothing but the distribution function of the random variable y is equals to P of y less than or equals to y. So it's nothing but, here what I told you that many values. For example, in the previous figure, x1, x2, x3. So x1, x2, x3. These three values are corresponding to a single value here, y naught. So these three values are corresponding to a single value here, y naught. Now, see here, x1, x2, x3. These three values are corresponding to a single value, y naught. So here, I am taking first the probability up to y naught. So Fy of y naught equals to what? The probability of the event y is less than equals to y naught. So it is nothing but the probability of the event, nothing but y takes less than equals to y naught. That is nothing but up to this. So that probability is nothing but what? P of x. Nothing but what? P of x such that what values of x you have to consider such that y is less than equals to y naught. So what values of x are correspond to the value of y naught? x1, x2, x3. Nothing but what? P of x1 plus P of x1. P of x3 is equals to x1 plus P of x1 to x2 and P of x2 to x3. So these three values are corresponding to a single value. That's why, so instead of mentioning x1, x2, x3, I am writing here P of x. X may be x1, x2, x3. So all the values of x such that, and what about y here? Y is less than equals to y naught. So what about y here? Y is less than equals to y naught. So the values of x you have to consider such that these values of x corresponding to the values of y naught. Y is less than equals to y naught. Now, in the probability density function properties we have seen. So probability of an event x1 less than x less than equals to x2 is nothing but integration x1 to x2 fx of x dx. This is in the case of a continuous random variable. Okay, now here what is x1, x2 are the ranges. But for what values of x here, consider here where the values of x such that all the values of x should be corresponding to y less than equals to y naught. So this range how I am writing is for all the values of x such that they corresponding to the y is less than equals to y naught. For these values only I have to consider. Only these values of x. Not the other values of x you have to consider in this particular example x1, x2, x3. So like that in general I am going to take here all the values of x such that the value of y is less than equals to y naught into what here? Fx of x dx. So this is a formula. So from this property here you can write. Therefore, what is Fy of y naught is nothing but Fy of y naught is nothing but P of y less than equals to y. Nothing but what? The probability of y less than equals to y, because these two are mapping. Nothing but they have the same probability. Therefore, P of x is the values of the probability of values of x such that y takes less than equals to y naught. So from this you are writing here. Now what do you want to calculate? You want to calculate the density function. So how do you get the density function? The relation between the distribution function and the density function is what? Fy of y equals to what? The differentiation of the distribution function gives the density function. Therefore, differentiate both sides the equation, let us say 1, for example, let us say this is equation 1. Then what do you get here? D Fy of D. So this is a formula. The density function and the distribution function relation. So D Fy of y naught by dy naught is equals to d by dy naught of, so what you are having here? X. The values of, what is the range here? All the values of x such that y should be less than or equals to y naught. And here fx of x into dx. So here I am taking only y naughts in this example. Now in general, in place of y naught I am taking y. I am considering here y. So y may be y naught, y1, y2, y3, whatever it may be. I am considering a general value y. Then replace this y naught by y. Then what do you get here? D Fy of y by dy. So replace here y naught by y. Then it's nothing but what? The density function. Nothing but fy of y is equals to what? Here on the RHS side, what you have here? D by dy of. So d by dy of integration x, the values of x such that y should be y less than equals to y naught fx of x dx. That equals to fx of here. What I am doing here? The differentiation with respect to y. Therefore, what do you get here? Dx by dy. Now, what's nothing but what do you mean by integration of x less than equals y naught and fx of x is nothing but what? You can write as what? Sigma n fx of xn. It's nothing but what? Fy of y. Now, how we are writing this equation like this? Integration nothing but what? Summation only. So, in the previous example, so the values of y naught are corresponding to what? The x, x1, x2, x3. Is it right? Then, so what is fy of y naught is nothing but what? So it is corresponding to three values. It's nothing but what? Fx of x1, or else you take like this also. So the probability is such that y less than equals to y naught is nothing but what? The probability that x takes x1, probability that x takes x2, and the probability that x takes x3. It's nothing but you can take it as the density function also. So fy of y naught is nothing but fx of x1 plus fx of x2 plus fx of x3. So nothing but here what is y? Nothing but all the values of y less than equals to y naught is corresponding to what? For what values of x? When x is x1, x2 and x3. When x is x1, x2 and x3. Then how we are adding here density function? Fy of y naught nothing but what? Fx of x1 plus fx of x2 plus fx of x3. Nothing but you can write as what? Sigma n fx of xn. Therefore, I am writing this integration nothing but sigma only. For continuous you will take what? Integration. For discrete you will what? Take the sigma. Sigma for what values here? For the values of x such that y should be less than equals to y. Nothing but I am taking what are the values of x, y less than equals to y naught is nothing but I am taking in this example x1, x2, x3. So in general how can I write here? Sigma n. Here n equals to 1 to 3. n to 3 fx of xn. In general you can write down here sigma n. You can many values of x, even infinite values of n. xn can corresponding to the value of y in the random variable y. That's why I am not writing the upper limit here. Just in general I am writing here sigma n fx of xn dx by dy. And if it may be increasing or decreasing, simply write down the modulus. It's just simply by modulus. So then what is the density function of the transform random variable y? Fy of y is equals to sigma n fx of xn into mod of dx by dy. So there is nothing but what here? Sigma n fx of xn by, you can write as what? Mod of dy by dx also. Where what is y equals to t of x. And what values of x here? What values of x here take here? X equals to xn. For what values of x here take here? Only at x equals to xn. That's why I done here only at x equals to xn. So this is a formula to calculate the density function of the transform random variable in case of non-appointed transformation and a continuous random variable. Now let us see the density function of the non-monotonic transformation random variable for what type of random variable we take here? Discrete random variable. The type of transformation is non-monotonic transformation and the type of random variable you are taking as discrete random variable. Now the density function of the transform random variable. What type of random variable? Discrete random variable. What type of transformation? Non-monotonic transformation has been given by Fy of y is equals to sigma n p of yn into del of y minus yn. So this is the density function of what? A discrete random variable. So in the previous lecture already we have seen how to write down how to represent the distribution function and density function for a discrete random variable. So the density function for a discrete random variable, we can write down the sum of the probabilities with what? The impulse function. Here what is del of y minus yn? That represents the impulse function. So nothing but what? Del of y minus yn. That equals to 1 when y equals to yn and 0 otherwise. That is a definition of the impulse function. So this already have discussed in the previous lectures. The density function and distribution function of discrete random variable. And similarly, the distribution function of the transform random variable for non-monotonic transformation of a discrete random variable has been given by distribution nothing but capital F, density nothing but small f. So f y of y. So y represents what? Distribution function of what do you want to calculate? The transform random variable. What is the transform random variable here? Y, because y equals to t of x. So fy of y is equals to sigma n p of yn into u of y minus yn. So this u of y minus yn is a unit impulse function. Nothing but this is 1 when y is less than or equals to yn and 0 otherwise. So the distribution function will be written in terms of unit step and the density function can be written in terms of impulse function. If you plot the graph, you will get like this, the impulse function, the density function. And if you plot the distribution function like this, you are going to get the distribution function for discrete random variable a staircase waveform, and the density function will get in terms of impulses. Okay. And here what is y equals to t of x? Then what is yn equals to t of xn? Then what is the probability of yn is equals to probability of xn only? Nothing but what? Yn nothing but probability of y equals to yn, nothing but probability of x equals to xn only. Okay, this is the distribution density function for a discrete random variable of a non-monotonic transform random variable, and the density function of the non-monotonic transformation of continuous random variable has been given by fy of y is equals to sigma n fx of xn by dt of x by dx, where x equals to xn. So let us solve a problem on this. If x is a continuous random variable with PDF, here PDF is nothing but probability density function fx of x, find distribution function and the probability density function of a random variable y equals to a x square, where a is greater than 0. So a is a positive value. And here what does it mean? Y equals to x square. Nothing but what? For example, if x equals to minus 1, what is y value? So a into minus 1 square, nothing but a. If x equals to 1, what is y value? A into 1 square, nothing but what? A. So if x equals to minus 2, what is y value? A into minus 2 square, nothing but 4a. And if x equals to 2, what is the y value? A into 2 square, nothing but what? 4a. It means the minus 2, x equals to minus 2 and 2 are corresponding to a single value y in the random variable y, 4a. So minus 2 and 2 are corresponding to 4a. So what is minus 2 and 2? These are the values of the random variable x. And what is the 4a? It is the value of the random variable y. So single value of y corresponding to many values of x. Therefore, from this you can understand that the type of transformation here it is what? Non-monotonic transformation. Non-monotonic transformation. For non-monotonic transformation, and here x is what they are given, that continuous random variable. So which formula you have to use here? If x is a continuous random variable, non-monotonic transformation, the density function has been given by sigma n fx of xn by mod of dt of x by dx, where x equals to xn. That formula you have to use it. So write down the formula here. Fy of y is equals to sigma n fx of xn by mod of dt of x by dx, where x equals to xn. So this formula you have to use now. Now what they are given, this is a square law transformation actually. If you plot on a graph, how do you get? At x equals to 0, what is the y value? 0. At x equals to minus 1, nothing but a. So at minus 1 and a, it is a. Let us say this is a. Let us say this value is a. At x equals to 2 and minus 2 is 4a. So like that. Because a is a positive value, it is increasing. So this is also called as what? Square law transformation. Now, so given y is equals to a x square. So from this, for any value of y, can write as what? Y equals to ax square. So this represents a random variable. This smaller represents a particular value of the random variable, and small x represents a particular value of the random variable capital X. Then from this y by a is equals to what? X square. From this, what is x equals to? Plus or minus square root of y by a. That is, what is x values? Minus root of y by a, and one more value is plus root of y by a. Nothing but x1 equals to minus root of y by a, and x2 equals to what? Plus root of y by a. These two values are corresponding to a single value y. That is the meaning here. Therefore, this type of transformation is what? Non-monotonic transformation. Now, what do you want in the formula? Here, you have to find it out dt of x by dx. That is, what is t of x? Nothing but y only. Nothing but you have to calculate dy by dx. Okay, then dy by dx. Or you can take dx by dy is equals to what? Plus or minus, and the differentiation of root of y by a. So nothing but here root y by root a. So the differentiation with respect to what? With respect to y. So dy of. So plus or minus 1 by square root of a, because the differential with respect to y. So root y is nothing but what? Y power 1 by 2. And what is the differentiation of y power 1 by 2? Nothing but y power, what is d root y? Nothing but y power 1 by 2 minus 1. Nothing but minus y power minus 1 by 2. Nothing but root of y. Nothing but 1 by square root of plus or minus square root of a into y. So this is nothing but dx by dy. Now, so what is x1 equals to? You are taking negative value. Therefore, minus square root of y by a. And what is x2 equals to here? Plus root of y by a. Then what is dx1 by dy is equals to? You'll get here minus. So minus 1 by square root of ay, and dx2 by dy is equals to 1 by square root of ay. Now we got the, then write down what is fy of y is equals to sigma n fx of xn by mod of d of t of x by dx at x equals to xn. That is nothing but what? Sigma n fx of xn into, so d of t of x by dx, nothing but what? Dx by dy only. So mod of dx by, and what is t of x? Nothing but dy only. What is t of x? That is nothing but y equals to t of x here. So mod of dx by dn, where x equals to xn. Here, how many values of x are having? Only 2. Therefore, I can write this as what? For n equals to 1 to 2 fx of xn into mod of dx by dy at x equals to xn. Now, you just expand this equation, then what you are going to obtain here? Fx of x1 into dx by d, so dx1 by dy plus fx of x2 into dx2 by dy. Then what can you obtain here? It equals to, what is fx of x1? Here what is x1? Nothing but minus root of y by a. Therefore, fy of y is equals to, from this equation I am writing here from equation 2. So fx of x1, what is x1 here? Minus root of y by a into what you are having, dx1 by dy. So what is dx1 by dy? So minus 1 by root of ay. So minus 1 by root of ay plus, next what you are having here, fx of x2. So fx of x2, what is my x2 here? Root of a by b. Into what is dx2 by dy? I have take 1 by square root of a by. Okay. Therefore, this is the density function of the transform random variable in case of non-monotonic transformation. So you don't know that whether it is monotonically increasing or decreasing. So that's why in general, how can you take it as? In place of this, can take it as mod. So I am taking as here mod. Then how can I write down here? Fx of minus root of y by a plus fx of root of y by a by square root of a into y. Sorry, here when you are differentiating, so what you are getting here? Differentiation of y power 1 by 2 by dy with respect to y, nothing but 1 by 2 into y power 1 by 2 minus 1. So d root of y by dy. Nothing but 1 by 2 into y power minus 1 by 2. Nothing but 1 by 2 root y. This is here I have to write down here 2 also. And here also write down 2. And here also write down 2. So here 2. So this is the density function of the transformed random variable y in case of non-monotonic transformation. So in today's lecture, we have discussed about the non-monotonic transformation for both continuous random variable and discrete random variable. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.